thank everybody for coming out. And because Lenny's going to run a little long here, I'm going to get out of the way and let Lenny take over right now.
All right, welcome. Thank you, Terry. Thank you for inviting me to deliver this tech talk, and welcome everyone. This talk is all about SQL Server Data Tools, and I will be running through a bunch of slides first to give some background information, and then the rest of the session will be all demos. So very often my sessions are like a little slides, then some demos, then some slides, then some demos back and forth. But in this session, it's just going to be a bunch of slides to start and then switch to demo for the rest of the session. Also, because this session normally runs a little over an hour, I'm probably going to rush through the slides a little quicker than usual. I think we got a smart bunch here, and I don't think there's any harm in rushing through the slides since the demos are going to basically just reinforce all the concepts of the slides. So with that out of the way, let me flip over to my deck here, and again skip through the introductory stuff about me you don't need to know. I got a new book out. It's not new anymore, but the whole first chapter of this book is on SSDT. Slides and code can be downloaded, and now let's just start with the session. Like, what is SSDT? What is SQL Server Data Tools? So SQL Server Data Tools is tooling that's inside of Visual Studio, database tooling that is integrated in Visual Studio. And this is not Microsoft's first attempt at bringing database tooling into Visual Studio. If you're familiar with the Database Professional Edition, or DB Pro, also affectionately known as Data Dude, this SSDT product is really positioned to utterly replace DB Pro. You can really think of SSDT as an evolved implementation of DB Pro. However, in terms of SQL Server Management Studio, to be clear, SSDT is not a replacement for SQL Server Management Studio, or SSMS, which is still alive and well and is the primary tool used by DBAs for managing and administering SQL Server instances. So, like I said, instead, you can think of it not as a replacement for SSMS, but as a replacement for DB Pro. So what the SSDT team has done is they have assessed all of the types of activities that a developer typically conducts inside of Management Studio and brought them in to SSDT inside of Visual Studio. So the first benefit here is that you're not constantly toggling back and forth between Visual Studio and Management Studio. And while that's nice, that's really the least of the benefits that SSDT offers. I mean, it's nice we don't have to toggle back and forth, but SSDT offers a lot more than just bringing common SSMS functionality into Visual Studio. So the truth, though inconvenient, is that our job is difficult. It's very hard to get things right when you're designing databases, and I'm talking now about the proper design and normalization, the intricacies of T-SQL as a language, performance tuning, and all of these things. They're all difficult in and of themselves, but with respect to the development process itself, there are definitely a number of pain points that could be remedied if you had the right tooling, and SSDT aims to deliver that tooling. So let's go through these pains quickly, starting first with dependencies, right? So by its very nature, a database is chock full of dependencies between different types of objects. Tables reference columns, views reference tables, stored procedures will reference tables, views, and other stored procedures, and so on. And as a result, very often changes that should be simple are become complex because of all the dependencies that are involved. Late-bound error detection is another pain point. You can spend a lot of time working on a script trying to get it just right, only to find out that there are problems with it when you run it. And it would certainly be nice to know about a lot of these problems earlier, before you attempt to run the script. Sometimes production database will change without us knowing. We'll deploy the database, but then in production, some DBA may come along and tweak something or add an index or perhaps make some other change. And at that point, the database has fallen out of sync with what we in our application expect it to be, and those differences need to be identified and reconciled. Versioning and source control is another big problem. So we've grown so accustomed over time with working with change scripts that it makes you wonder, where is the definition of the database itself? Of course, you can rely on it being in the database, but where is it from the standpoint of preserving and protecting it? Right? It's very easy with source control to go back to an earlier version of your .NET application, but it's much more difficult to do the same thing with your database, to roll your database back to some earlier point in time that lines up or corresponds with some earlier version of your application. And finally, it's becoming increasingly difficult to target different versions of SQL Server, where you might have one database that needs to be deployed to multiple locations, where across those locations, different versions of SQL Server are running. It could be SQL Server 2005, 2008, 2012, 2014, and increasingly now, of course, SQL database, Microsoft Azure SQL database, which is the cloud version of SQL Server. So many of those pain points stem from the fact that the database is stateful, right? That's its nature. And as a result, it becomes a challenge because we don't only have to concern ourselves with the design of the database, we also need to be concerned with how we move that idea of our design into a stateful database. For example, how do you deploy a table or a view or a store procedure? Well, if it's new, then it's a create statement. If it exists, then it's an alter statement, right? So these are things that you need to be concerned with in addition to the actual design of the database itself. So the solution is to work declaratively, and that's the approach that SSDT takes. To work not imperatively with change scripts, but instead declaratively, where you just work with a declaration of how you believe or how you want the database to be, and you let the tool worry about generating change scripts, getting it just right to move those ideas into a stateful database. This lets you focus on just the design while the tool handles generating these change scripts correctly. And here's the key concept that you got to lock down when you're working with SSDT. It's a model-based approach, meaning you're not really working directly with a database. You're working with a database model. And when I say model, I'm referring to an in-memory representation of the entire schema of a database. I'm not referring to like an entity data model or some sort of visual model that you might see on the screen. When I say model, I'm talking about all the schema information about a database that's contained in memory. And the tools operate against that model. And in turn, that model can be backed by either a connected database, and in that case, the experience is very similar to what you have today with SSMS when you're working with a connected database imperatively. Or it can be backed by a database project working in an offline mode. Or it can be backed by a database in the cloud on Azure, or it can be backed by a snapshot of a database that you can take, which is really just a serialized representation of this model that you can take at any point in time to create a snapshot of how your database looks. And the beauty of SSDT is that the same tools work the same regardless of how the model is backed, right? It's the same experience. So all the features, that is the table designer, IntelliSense, real-time validation, refactoring, schema compare, and many more that you're about to see demoed, they all work the same regardless of how the database, of how the model, is backed. So here's a little slide that kind of graphically illustrates what I was just describing. You have SSDT, which are the tools. They operate over the model, and the model in turn can be backed by either an on-premise SQL Server database as far back as 2005, so support goes back that far. It can be a database project, which is when you're working offline. And when you do work offline with a database project, you also get the local database runtime, or local DB as it's called, which is kind of like a trimmed down version, even more express than Express. We'll talk more about it a little later, but the idea is that it's a non-production environment for you to do your testing of your project before you're ready to deploy the project. It can be backed by an Azure SQL database in the cloud or one of these snapshot files that I started mentioning. It's a database snapshot file with a DACPAC extension, which again is just a serialized representation of the entire model. So we're going to put SSDT through all these paces. I want to try to kind of rush through this rest of these slides. We're going to see all of this stuff working in a demo coming up. But when you're working connected, you'll see that inside of Visual Studio, you have an Object Explorer that's very similar to the Object Explorer that you see in SSMS, but it's not complete, right? Like I said, it's only the developer-focused features that have been brought into SSDT that you'll have access to in the Object Explorer. You get a query window, very similar again to SSMS, so that you can execute queries directly against the connected database. But again, because of this kind of disconnected or decoupled architecture, I should say, where even when you're working connected, you're somewhat disconnected in the sense that the tools are operating against the model is backed by a connected database, and for that reason you get this special feature called Power Buffer. And I'm not going to discuss Power Buffer now because you're going to see it in a live demo in a moment. But Power Buffer is a feature that you get when you're working with in a connected fashion. But the preferred way of working with SSDT is in a disconnected fashion, offline with a database project. So it's great that you can connect directly and work for doing ad hoc queries or ad hoc updates, what have you, when you need to do something quickly. But the real preferred way when you're doing serious large-scale development is with a database project where you're not working with a database, you're working with a project that represents a database, and inside the project you have files that collectively describe the entire schema of a database. Every table, view, stored procedure, user-defined function, user-defined type, you name it, is going to exist in the database project to represent a database. And while you are developing this project, you're working offline, but you do have this local DB that I started mentioning, and you'll see it again soon, which is a lightweight, single-user, single-instance version of SQL Server that you can use to test your project against. You can take a snapshot at any point in time, so over time you can have different versions of your entire database schema that you can always roll back to, and because you're dealing with a database project and not a database itself, you'll see that the project has a property that lets you specify which version of SQL Server you intend to deploy the project to. And that allows Visual Studio, or I should say SSDT inside Visual Studio, to validate and ensure that everything that you're trying to do in your project is valid for the specific edition or version of SQL Server that you want to deploy to. Schema compare is pervasive throughout SSDT. It occurs everywhere. The key point to lock down here again is that you're not comparing two databases, you're comparing two database models. Now, a source and a target. Of course, both the source and the target can be backed by an actual database, in which case you are comparing two databases, but the source or the target could be any one of those things that I mentioned can back a model. So you can compare a project with a database, or the opposite, a database with a project. Or you can compare a database project with an earlier version of your project that you've preserved in a snapshot. So it's pervasive. It happens all over the place. Sometimes, as you'll see in the demo, it just occurs in the background. There's no user intervention. It just does the schema compare, generates a script, and runs it. Other times, it's a rich interactive experience with color coding, and you can really see the differences and be actively engaged in the process of applying the change script. Okay, we're almost done with the slides. We'll be able to jump into the demo. I would like to say, though, of course, that no tool is perfect, and SSDT is no exception. There are a few things missing. There were more things missing when it first started. It didn't support data compare, it didn't support database unit testing, and it didn't support data generation. All of those were features that are available in DB Pro or DataDude. Over time, they've released updates where the only thing that it's still missing that DataDude has is data generation, so it can't generate data. And also notably, there's also no graphical query designer. There are no database diagrams, so if you're familiar with database diagrams in SSMS, you know that it makes it very easy to establish relationships between tables without having to write NET SQL. You can just drop two tables onto a diagram and use the mouse to draw the relationship from one table to another, and you get your foreign key added to the database automatically. You don't have that in SSDT, which is somewhat unfortunate. It has to be done in T-SQL, but as you'll see in the demo, it's not that bad because at least we won't have to memorize the syntax. We just have to plug in a few things. Other notable omissions, there's no spatial results viewer, so if you're doing spatial development, you won't be able to see those results graphically like you can in SSMS. And there are no command line tools, which is unfortunate. At the outset, they always talked about there being command line tools, like doing a schema compare from the command line. That didn't happen, and it still hasn't happened. And I really don't know what the status is with that. Installing SSDT, well, I'm going to assume most of you are running at least VS 2012, if not 2013, so then you already have it, unless you actually explicitly unselected it during setup. then otherwise you have it already. It was released at the time that VS 2010 had already been released, and so if you're still running 2010, you need to get it from this link. You just go to that link and you click on Get It, and it will install SSDT. All right, that's it for the slides. The rest of this session is all demo, and for that I've got a machine here ready to go. This is my Windows Server box, and I've already got Visual Studio up and running. So let's go ahead and just dive right in. Here I am in Visual Studio 2013, and what I want to do is show the SQL Server Object Explorer. So first I'm going to show connected development, right? It's a good place to start because it's a comfort zone for all of you that have been working in SSMS all this time, all these years. So we want to show the SQL Server Object Explorer, which you can get by pulling down the View menu and saying View SQL Server Object Explorer. I'll pin that down. Right now I have no connections, but I'll right-click and I'll add a SQL Server connection. And I'm going to add my local instance of SQL Server, which, so, as you know, I can just refer to that using the dot syntax, which means localhost, or I could actually type localhost. But I'm actually going to type the name of my machine, and it'll be a little clearer later on as to why I'm doing that. So I'm actually specifying the name of my machine, SQL 2014 Dev, and there's the connection. And for this demo, we're going to treat this as our production database. It just happens to be running locally because this is a demo environment, but let's all just imagine that this is some production server hanging out on our network, and that's our production server. And when I expand it out, you can see I've got a handful of databases there, but I'm going to now create another one for this demo. So I will right-click on the instance and say New Query, and I'll get a query window. And in this query window, you can see, again, it's very similar to SSMS. If you look at the status bar on the bottom, you can see the connection status, the server you're connected to, the user you're connected as, the current database. You've got the drop-down at the top to set that. As with SSMS, this defaults to master, so you still need to be careful that you don't trample over it. But in this case, we'll be creating a new database, so it's fine that our current database is set to master at this time. So I have this script ready to go, tucked away in Notepad, that I'll just copy and paste. And let me explain what's going on in this script before I execute it, okay? I'm creating a database here called SampleDB. May as well be called SimpleDB because it's a very simple database. It has a customer table with a customer ID as the primary key, first name, last name, and this customer ranking column. Then I've got an order header table with a foreign key for the customer ID and the total dollar amount for the order, and I'm stopping there. I'm not going into order details, and I'm not adding any more columns, but I am establishing the relationship between the customer table and the order header table on the customer ID column in both tables. Then I'm just inserting a few customers. Here I'm inserting 6 customers and into the customer table, and in addition to that, I'm inserting into the order header table a bunch of orders, 2 for Jeff, 1 for Keith, 2 for Simon, 2 for Matt, and 3 for April. Hopefully most of you, or if not all of you, are familiar with this syntax. So this is a single insert statement, but it's inserting multiple rows, right? So now that I've explained, oh wait, there's one more part to the script, and that is this very simple view at the bottom called View Customer Order Summary that simply joins the customer on the order header using the customer ID, foreign key, and primary keys in both tables in order to be able to do a group by and give us the sum of the order totals. So for each customer, we should still see one row only in this view with the total dollar amount of all the orders for that customer. Like I said, a very simple database, which I would like to now create by executing this script. You might be inclined to think, hey, I should just hit F5, right? I mean, that's what I would do if I was in Management Studio. But we're not in Management Studio, right? We're in Visual Studio. And F5 has a very different meaning in Visual Studio, right? In Visual Studio, F5 means build or build and deploy my project. Well, I don't have a project yet. That's going to come up a little later in the demo when we start working with a project. I'm working imperatively here. So I have no project, and therefore it's a different keyboard shortcut to execute this script. And that keyboard shortcut is Control-Shift-E, or if you right-click to get a context menu, you can see, indeed, like I said, the keyboard shortcut for execute is Control-Shift-E. So I'll just give it a run, and it has created the database. You can see 6 rows affected. Those were for the 6 customers that were inserted, and 10 rows affected for the 10 orders that were added. And now we can see that we have our database. If I refresh the SQL Server Object Explorer on the left, you can see the sample database. And if I expand it out, you can see the tables that I created, the customer and the order header table, as well as the view, the customer order summary view, right? So continuing on inside this window, after I executed the script, while I've been talking, SSDT has kind of sucked into memory all the schema information about this database. So if I start typing ad hoc code here from customer, as soon as I start typing, you can see the IntelliSense pop up. Now, I realize that IntelliSense alone is not sufficient to impress this crowd, but the point that I'm trying to make here is not so much about the IntelliSense as much as the IntelliSense is being driven by the model. So the IntelliSense is coming out of the model, and the model is being backed by, in this case, a connected database, but later on, it'll be backed by a project, and we'll still have the same IntelliSense experience. So I want to look at all the rows in the customer table and all the rows in the view, and there's my IntelliSense again. And if I hover over customer, I get a tooltip telling me that's a table. If I hover over VW customer order summary, the tooltip tells me that's a view. If I hover over the asterisk symbol representing all columns, I get a tooltip showing me all the columns represented by the asterisk. Again, all of this rich metadata coming out of that in-memory model that is currently backed by the connected database. And just like in Management Studio, you don't need to execute all the code inside of a query window. You can highlight just the portion of the code that you want to execute, and now I'll hit Control-Shift-E. And you can see there we have it. There is my customer table. And here is the view that shows the sum of orders for each customer. So this looks good. And you can see that I was able to work with SQL Server in a connected manner, very similar to the way you might do the same thing in SSMS. So life is good. We're ready to go home at the end of a long day. Except right when we're walking out the door, we get an email from marketing with a bunch of change requests. They want us to change a few things in this database design. And in the email that they sent us, they also included a spreadsheet. So the problem really centers around this customer ranking column, which you can see is, and you saw when we created the database, is just a text column. So if you throw up a text box on the screen for people to type whatever they want, of course you can't expect any consistency. We have somebody type so-so, somebody type A+, you've got blanks, you've got nulls, it's just a mess. And so what the marketing team would like us to do is retire this column here and replace it with a more formalized ranking system. And this is the spreadsheet that they've attached to their email, where they want us to rank our customers based on their order performance between 1 and 5, which corresponds to these rank labels, inactive up through platinum, depending on the range that their total orders falls in. And that's how they would want us to modify this database. And oh, by the way, they want it done. They also want it deployed to Azure, and they want it done by Friday, and it's Thursday night. So the pressure is on, and we got to get all this done. And SSDT is going to help us do this quickly and efficiently. So we give it some thought, tossing and turning all night Thursday night, and we wake up in the morning and we put together this task list, and this is how we're going to tackle these requirements. First of all, of course, we are going to remove that customer ranking column, that text column that has all that garbage in it. We're going to retire that column, and we're going to create a new table called customer ranking. It's just going to be a reference table that is going to contain these 5 rows of data, right? We're going to load these 5 rows of data into our new customer ranking table, and then back in the customer table where we remove that bogus text column, we'll add a foreign key column, customer ranking ID, and then create the relationship. Really, 3 and 4 go together, right? You create the foreign key column in the customer table, and then you create the constraint or the relationship between the customer and the new customer ranking table. Then we can update the view that we just saw to join against customer ranking, so we can show those labels, bronze, inactive, platinum, etc. Finally, we're going to create and debug a stored procedure that will update our customer rankings, and if all goes well, we will deploy to the cloud as well. So what I'm going to do is, step 1, I'm going to perform still while working connected, because I want to demonstrate power buffer. But once we get this step done, we will complete all the rest of these steps in the preferred way of working with SSDT, which is offline or in a disconnected fashion using a database project. So let's go with step one, removing that customer ranking column. Back inside of Visual Studio, I'll go over to my table here and right-click on customer and say View Data. I'm sorry, not View Data. My bad. Don't need this one anymore either. I'm sorry, I meant View Designer, of course. And what you get is a designer which at first blush looks perhaps a little similar to SSMS. I mean, this grid on top looks very much like SSMS, but this code window on the bottom looks new. And basically, you're really looking at two views of the same thing. So this thing works bidirectionally. You can edit the grid on top, and the code will update on the bottom, or vice versa. Edit the code on the bottom, and the grid will update on top. So this is code, to be sure, but it's also code that we know can't really be executed as is, because it says create table, and we know that the customer table already exists. So if we try to run this script, it'll fail because the table already exists. But again, that's the point of working with this tool. We don't care if the table exists or not. We just see it as a create table statement. The tool automatically will figure this out. Now you might say to yourself, hey, don't I kind of get this functionality in SSMS with its table designer? In a sense, you do. True, you can use the table designer to create a new table, and when you save it, SSMS will issue the appropriate create statement. And then if you load that table back into the designer to make a change and then save the change, SSMS will figure out the appropriate alter statement. That is certainly true, but that's also where it stops with SSMS. And SSDT takes this concept much further. So let's have a look. Let's get rid of this customer ranking column. You can see when I highlighted it on top, it's actually highlighted on the bottom. I could delete it from the top or the bottom, but I'm just going to delete it from the top. I press the delete key. It's gone from the grid on top and from the code on the bottom, and that was my first change, right, just to drop that column. And that was a very simple change to make. Pushing that change to the database should be just as simple. So I'll go ahead and click this update button, but unfortunately, instead of working as we would have liked, it fails with these errors. It looks like complaining about something in the view here, and then again here. A little further down, it looks like there's a case sensitivity issue. Something differs only by case. But whatever it is, we can't update the database. We're blocked from updating the database. So I'm going to tell you that these really are errors. So we have to fix these view errors. These on the bottom, the case sensitivity issues, those are warnings. They alone would not have blocked us from doing the update. Now, we could have known about these problems even before attempting to update the database by clicking update, if we would have just had the error list being shown. So here you can see those, like I said, the case sensitivity issues are warnings, and you can see that by the icon. But the view issue is an error, and it's blocking us from pushing the change to the table. So one of the goals of the SSDT team was to give you an experience when doing database development that's very similar to the experience you have doing ordinary application development. If there's an error, you should just be able to double-click the error in the error pane and navigate directly to the offending code, and you see we have that exact same experience. I don't have to dig for it. I just double-click on the error in the error window, and it brings the offending code into view. Now, you might have noticed that I created this view with schema binding, and what that does is it really protects us from breaking the database. That is, if breaking a view because we've changed the schema of one of the underlying tables used by the view, which in this case, we've dropped this customer ranking column in the table designer, but this view that has schema binding relies on it, and so we're blocked from doing this update. Now, we know that in the later step, after we create the customer ranking table, we're going to add another join for that and bring in the rank label. But we're not there yet, so we have to unblock ourselves. So the way I'll do that, at least temporarily, is to just comment out the offending code and kind of also demonstrate the experience in Visual Studio where as you correct a problem, the errors just go away. So as I kind of comment out this bad reference, you'll see that the errors just dropped. There's only one error left, and when I comment out the invalid reference in the group by, now that error is gone, and now I know I'm good, or mostly. I mean, there's some category of some types of errors that won't get caught until you try to deploy, but the vast majority of errors get caught before you try to deploy, and now I should be able to update. But now take notice. I have two windows open with unsaved changes. This customer table, where I dropped the column from, when I click this update button and it failed. And I also have the view open to a change I made where I commented out this customer ranking column. And it also has an update button. And, it might be reasonable at first to think that this update button updates just the view, while this update button updates just the table. But in fact, that's not the case. If you look at the tooltip, the update button says update database. And what's happening here is power buffer. I have two windows open with changes. Those changes have been applied only to the in-memory representation. When I made the first change, I broke the validation rules being applied to the in-memory database, and it wouldn't allow me to update the database because we had an error. I fixed that error by modifying the view, so now there are two changes that are in memory, that are buffered up, if you will, in memory. And I could now, at this point, open more windows and make additional changes to other tables and other views, and each one of those windows would have an update button that does the same thing, meaning push all the buffered up changes for all these open windows out to the database. It's something that can only be done if all of the changes that have been made in memory are valid, which is the case now. So it really makes no difference which of these two update buttons I click. I'll just click the same one I clicked last time when it failed. So this time, you'll see that I can update the database. So the update database button is not disabled. I still have those case sensitivity issues, and we'll clean them up a little, shortly. But you see, they're not blocking us from updating the database. Like I said, we have these case sensitivity warnings, but we can still update the database. So this is the very first time we're doing this. So we're going to have a look at the script that this generates. But really, over time, as you grow to become comfortable and trusting of the tool, you probably will just go ahead and click Update Database. But I would still caution you, even if you're not going to review the script first, to at least review this preview dialog to make sure that it's consistent with the changes that you expect to be made, starting with highlights. So highlights, we have something here we're being told that this column is being dropped. Data loss could occur. Data loss could occur? I think it's a safe bet that all the data in that column will be gone permanently. But of course, that's just a highlight. We have the warnings here, and we talked about those, how we'll clean those up a little bit later, but they're not blocking our update. But here's the most interesting thing to look at, and the most important thing to look at if you're not going to review the script. Look at the actions that the script is going to take. It has figured out what it needs to do and the order that it needs to do it in. It realized that it needs to first remove the schema binding before it can modify the table to drop the column, and then after that it can reapply the schema binding. So like I said, you would normally just click Update Database, but since this is the first time we're doing this, we'll click Generate Script to see what this change script looks like. And really this is essentially the result of a schema compare. When I clicked that Update button, it did a compare between my in-memory model that has the changes and the database that I want to push it to, and it generated this script, which has, let's see, up top it just sets a bunch of environment variables. Then it goes ahead and uses the database. It sets up a temp table for errors that might occur during the execution of the script. And then it takes its first step, which is to remove the schema binding from this view. If you look at this alter, you can see that it's the same view that we had, except that the keywords with schema binding have been removed. My other changes haven't been made. The customer ranking column that I commented out is not yet commented out because it's too early to do that. First, the schema binding needs to be removed with this alter. Then, after some error checking takes place, the script knows that it can alter the customer table to drop the customer ranking column, and that won't cause an error because the schema binding has been removed from the view. After the table has been modified to drop the column, and again some more error checking takes place, finally, the script goes ahead and alters the view one more time, reapplying the schema binding as well as applying the change that I actually made by hand, which is to comment out the offending code. And then finally, after some more error checking, it gets committed. I forgot to point out that this whole thing is transactionalized. So way up at the top, you're going to find somewhere here, there we go, you're going to find a begin transaction. Now, there's no reason that this should fail because it was generated by a schema compare that is generally reliable, but the more time I spend staring at this script and thinking about it, the greater window of opportunity is there for someone to come along to the database and change it, and so errors are possible, but this thing will either succeed or fail as a whole because it's been transactionalized. Now I'm going to go ahead and execute this script by hitting Control-Shift-E. And you see it went ahead and made those changes. It removed the schema binding, it altered the table to drop the column, and it reapplied the schema binding. So now we have completed step 1. And we're going to go ahead and move on now to step 2. Right, and like I said, we're going to, now that I've demonstrated Power Buffer, which is a feature available when you're doing connected development with multiple changes that are kind of buffered up in memory, we are going to move over to working with a project, which is, like I said, the preferred way of working with SSDT, because we're going to have a project that can be saved under source control and can be, we can work independent, offline from the production database. Right, the first change we made directly against the production database. So let's go ahead and do that. Let's first close all these open windows that we don't need anymore. Flip on over to Object Explorer, and I will right-click on the database and say Create New Project. I will name the project after the database, which I think is generally a good practice. And I'm going to create a new solution, but check this one out. I'm also going to check Add to Source Control. All right, so that's going to basically integrate with whatever source control provider I have plugged into Visual Studio. Also take notice of this folder structure setting. It's set to schema/objects type, and what this means is that the folder structure of the project that will be created will be a top-level folder for each schema in the database, and this is a very simple database with only one schema, the DBO schema. And then within each schema's folder, there will be a subfolder for each type of object in that schema, so one for tables, one for views, stored procedures, and so on. And then within those subfolders, you'll have individual T-SQL files. And that's going to be the structure of our project. I'll go ahead and click Start, and because I have chosen to add to source control, I can choose Git. But this will work with any source control provider that you may have. So the same is true for Vault, SVN, and even, dare I say, Visual Source Safe. It will work with any source control provider that you have plugged into Visual Studio. So now what's happening is that SSDT is scouring the database, trying to discover every bit of schema information that it can in order for it to be able to generate the project. You can see all the things that it has found. It is done. I'll click Finish, and now look over on the right-hand side in Solution Explorer, where you can see it has I have my project. Let me also keep Object Explorer open on the left here. So here I am on the right side looking at this solution with a project that has, there's that DBO folder for the DBO schema. There are the object type folders. I only had tables and views in the database. If I had at least one stored procedure, I would also have a stored procedures folder here. And then within each one of these are the customer table, right, my 2 tables and my single view. So the idea here is that, when you're working here on the right side with Solution Explorer, you got to realize you're working disconnected, offline, as opposed to working on the left side of the screen with the SQL Server Object Explorer, which means you're working live against a connected database. Unless, of course, you're one of those people that moves the Solution Explorer from the right side to the left side. Don't you hate those people? Okay, I know you know who you are. But we won't go there. We'll just keep the Solution Explorer up on the right for disconnected offline development. You can also see the icons there indicating source control, the little green plus sign. So we do have integrated source control. Before I commit this to source control, though, I'm going to create a snapshot. This is one of those DACPAC files I was talking about earlier. Just right-click on SampleDB and choose Snapshot Project. What that does is you can see here it builds the project, and we'll talk shortly about what it really means to build one of these projects. And it created a snapshots folder, it created the DACPAC file, and it is suggesting a name that includes the current date and time, which is nice, but I'm going to choose my own name. I'm going to call it version 1 baseline.DACPAC. DACPAC stands for, I think, Data Tier Application Component Package File Format. So it makes it sound smart, but it's certainly a lot easier to just call it a DACPAC or a snapshot. So what is inside this DACPAC file is a serialized representation of our entire project. Whatever changes we make moving forward, we will always be able to roll back to this snapshot, or at least do a schema compare to see what changed between this snapshot and what transpired after we took the snapshot. And now I'm ready to commit all this to source control to protect all this code. and you can see the lock icon, so we can see that we're protected under source control. So now that we have our project, we can go ahead with step 2, which is to create the customer ranking table. And for this, we're going to go into the project and right-click on the tables folder and say Add Table. But of course, I'm not really adding a table to a database. I'm adding a file to a project, a file that represents a table, that when we deploy will result in a table being generated to the database. And I'm going to call this table Customer Ranking. And a designer opens that looks very similar to the designer that we were working with when we were connected for step 1. And that's because it is the same designer. Again, just driving home the point that regardless of how the model is backed, it's the same set of tools and it's the same experience. So I'm going to just go ahead now and build out this table. So I'll start off by typing up in the grid here, Customer Ranking ID. That'll be an integer, and it'll be our primary key. We also want a rank name. That'll be like silver, bronze, etc. We'll make that a varchar 20, and we won't allow nulls. If you keep your eye down here where it says null, and then when I uncheck allow nulls on top, you see the code change to not null. And just to prove that you can do this in both directions, I'll type on the bottom, and it tries to update the grid on top as you type, but if I pause long enough, you can see the syntax error. That's just because I haven't caught up yet. But if I finish typing everything and I type it correctly, I make it a varchar 50, there you can see that the error went away and it has added it. It's allowing nulls, but if I type the words not null, you'll see the checkbox disappear. In fact, there's a third place that I can go to change the design besides the top and the bottom panes, and that is the Properties panel, or the Property grid. Okay, so here you can see that the length is 50, but I can change it to max, and when I do change it to max in the Properties window on the right, you'll see it change both on top and on bottom. The grid on the top is now changed to max, and the code on the bottom has now changed to max. So this looks good, and I'm ready now to save this file. So I'll click Save, and I've essentially just saved this file to my project. You can see the green plus sign there. And now, task 2 is complete. We created the customer ranking table. And now we're going to do task 3. Like I said, 3 and 4 kind of go together. We're going to add the customer ranking ID column. We're going to essentially establish a relationship between the new table and the customer table on customer ranking ID. So I will go back to my customer table and open it in the designer. Again, I'm in the project now, so nothing I'm doing here is affecting our production database. It's only in the project. And I'm going to add the customer ranking ID column. Oops. And that'll be an integer. And we actually will allow nulls for now because we're going to be loading data initially with no values, and then we're going to populate values in that column, after which you might want to uncheck this. But for now, we're going to allow nulls. And that's our customer ranking ID column. I'll click Save, and that takes care of step 3. And step 4 that goes with it is to establish a foreign key constraint between this table and the customer ranking table. And here's where I said that it's unfortunate that we can't do this graphically with a diagram view where we just drop both tables onto the diagram and use the mouse to drag a relationship. Instead, we have to do this in code. But it's not that bad because at least we don't have to memorize the syntax. I'll right-click on foreign keys and say I want to create a new foreign key. It suggests a name that I'll give it a better name. By convention, I name my foreign key constraints after the two tables being joined. And you can see that the tool has stubbed in the code, so it's not really necessary for me to memorize the exact syntax for the foreign key constraint. I just need to get rid of those squigglies. So I know that this is the customer ranking ID column is the foreign key, which references the customer ranking table's same named customer ranking ID column, and pause for a moment to let the squigglies go away, and I know now that I've got my foreign key relationship in place. I'll save the file, and now step 3 and 4 are done. Okay, so at this point, before I proceed with step 5, I am going to press F5 to build and deploy the database. So I'm going to press F5 now. You can see it's doing a build. And two questions now. Well, first of all, what does it really mean to build and deploy one of these projects? And secondly, I've made no declaration of where I want this deployed to, so how does it know where to deploy it to? So to answer the second question first, this is by default that local DB that I was telling you about in the introduction. It's the local database runtime. How do you know this? Well, if you right-click on the project and go into Properties, in the Debug tab, you will see a connection string, the target connection string. This is the connection string that's used every time you press F5. And you can see that it's pointing to local DB, and those parentheses are not arbitrary. They're actually required. It's part of the server name. So if you're thinking like SQL Server Express, this is even more Express than Express. Even SQL Express fires up as a service when you boot Windows. This local DB spins up on demand in proc, and it doesn't actually support every feature of regular SQL Server. Like, I don't think it supports file stream. There might be some kind of edge features that are not supported. So here's what I can tell you. If you have something better, and as developers I think we all do, you can click Edit here and use something else instead of local DB as your test server when you're working with your project, which is where your project will get deployed to every time you press F5. Basically, any non-production server will do. Any server that you can make a mistake on and goof on and it won't have any serious consequence is suitable for this target connection string. So to answer the first question, what does it mean to build a project? It just means a schema compare. Well, first validate, make sure there are no errors in the project, and then create do a schema compare. The first time you do a schema compare when there's no database yet, well, then the schema compare generates the entire database. But subsequently, it'll be only incremental. So if I flip over to Object Explorer, you can see a new connection. Now, maybe it will be clear why I didn't want to call this localhost. It might be confusing to see localhost and local DB here. So this is our production server. It just happens to be running locally because I'm doing a demo. This is the local database runtime, or local DB, that is only able to run locally. It can't run any other way. So this makes it clear. This is production. This is for testing my project before I'm ready to deploy to production. And if you expand it out, you'll be able to see there's the sample DB database. Now, of course, there's no data in this database. It's all brand new schema that's been scripted out to the database. But you can see the new customer ranking table. And just to verify that I have not impacted production, I'll even refresh to prove that the changes I've made have not impacted production. Right? The new customer ranking table is not there yet. So now we're working, as long as we're working with our project and until the time we're ready to deploy back to production, it'll be the sample DB database under local DB that we work with. Okay, so now that that has been deployed, we can go ahead and, well, actually, before going on to our next test, I want to bring in some sample data. These tables are completely empty, and to get any kind of real testing done, I'm going to need some data. So let me show you how you bring over some data. I'm going to go into the production database, sample DB, and I'm going to open the customer table. And of course, this is just a demo, so there's only 6 rows. But being the production database, imagine there are 6,000 or 600,000 rows here, and we just need a handful. So I will just select the first 4 rows, right-click and copy, and now open up the customer table in local DB, which is where we're testing. View data, of course, it's empty, and paste. And it's interesting that even though I copied a table structure that had 3 columns and pasted it into a table structure that has 4 columns, it worked just fine because the 4th column allows nulls. Now we're also going to need to populate this customer ranking table. So the copy-paste feature really works with any tabular source. So if I view data and I see that this table is empty and go back to the spreadsheet that marketing sent me, I can even copy and paste out of Excel, and it'll even work out of a table in Word. Any tabular source that's copied to the clipboard can be pasted with SSDT directly into a table. And there, I've just populated 5 rows of that reference data into the customer ranking table. So we have 4 customers, and we have our complete reference table, and now we can turn our attention to the view. Right, we want to update this view. So let's go to the view back in our project. We're working in our project. And let's see, we have some squigglies here. So let's look what that's about. Well, it's complaining about differing only by case. So remember, these are those case sensitivity warnings. I told you we'd get around to fixing them. Well, now is as good a time as any. The squigglies are a little weird, but don't let that bother you. Essentially, when you have a case sensitivity problem, for whatever reason, SSDT puts a squiggly under the create keyword, and then it puts a squiggly under the first offender. But it doesn't put a squiggly under the other offenders. So the offender is the one with a capital D at the end. The customer ID column in the customer table has a lowercase d. Of course, by default, this is not a problem because by default, SQL Server doesn't care about case. But you can override that default, and you might deploy this somewhere where that default has been changed and things are case sensitive, and that would break. And even if not, we want our code to be squeaky clean. If you're like me, you don't want any warnings at all. So I'm going to just fix this up in here by doing a case sensitive search and replace. And that takes care of the case sensitivity errors. But now let's do what we really came here to do, which was to join on that new table. So I'll pull in the left outer join. I get IntelliSense helping us out. There's that customer ranking table. But here, this time, the IntelliSense is coming from a model that's being backed by my project, not by a connected database. I'm working with a .SQL file. If you look at the tab up top, I'm working with a .SQL file that's in my project, but I'm still getting the full IntelliSense. So it's the customer ranking table, aliased as R, on r.customerrankingid equals c.customerrankingid. And once we've done that, we can go ahead and pull it. We can finally get rid of this commented code and pull in that rank label. And from the ranking table, and we can also add that to the group by. Now, what I'm going to do, I'm running short on time, but I really want to show you this. True, you do need to deploy this, but you can actually test this before deploying to LocalDB. And what would happen if I hit Control-Shift-E here? Well, it sounds a little confusing. We said Control-Shift-E is used when you're working connected, and here we are working disconnected. Well, what will happen if I hit Control-Shift-E is that it will actually create a connection. It'll open a connection to the sample database running on my on LocalDB, where there is already a view called VW Order Customer Summary, so it should be no surprise that we would get this error, right? It has created a connection to LocalDB. Look down here where I'm hovering the mouse. And then it tried to run this create view, and of course that failed. But I can highlight just the select and execute that. And in other words, I can test out the select statement of my view without even deploying the view, even to LocalDB, let alone production. That's how early you can test these things, and I can even get a execution plan as well, which is very, very cool, right? With that in mind, I'm just going to go ahead now and press F5, which will build and deploy. It's going to do a schema compare. It's going to say what's different between the last time you did this, and it's going to say, oh, you added a view, and so it'll just go ahead and create that view in SampleDB, and there you can see it's there. So now task 5 is complete, and we're up to task 6, create the stored procedure to update customer rankings. But before we get there, I want to showcase another very cool feature of SSDT, and that is refactoring. So let's say it turns out that I realize I don't like the name of this table, customer ranking. I'm not ranking anything other than customers, so it's going to be shorter to just call it ranking. Globally renaming or refactoring in a database is something that's traditionally very difficult to do, but with SSDT, it's a piece of cake. You just find any reference, right-click, and say refactor, rename, and I just want customer ranking to be called ranking. And you're going to get, just like you get with .NET development, a preview of all the references. So I can see it inside of a table, I can see it inside of this view, and any other place where the change might be made. And I'll click Apply, and it has now been changed globally throughout the database, or I should say the database project, though this will work just the same if you're working connected. All right, and it has gone ahead and globally renamed that table throughout my entire code base. Unfortunately, one thing it doesn't do, it doesn't actually rename the file itself in the project. I think that's a very bad thing, and I raised it to the team at the time. They agreed with me that they thought it was a bad thing, but they never actually changed it. So we have to, rename that ourselves if we want to keep things neat. Furthermore, it would only stand to reason that customer ranking ID column name is too long. We just want it to be ranking ID. We've got two such columns, one in the ranking table and one in the customer table. So two refactor rename operations to change customer ranking ID to just be ranking ID globally in the ranking table. These are all the references. I'll apply it. I just made that change globally. And the same for the customer ranking ID column that's in the customer table. We'll just call that ranking ID. Now, when we switch on over to Object Explorer, you might have noticed earlier when I was working connected, it was necessary for me to refresh the tree view to see the change. But when you're working with local DB and you press F5, you don't have to press, you don't have to refresh. You're going to see it change. So I'm going to press F5 now, and keep your eye on the left here. Keep your eye on the customer ranking table. My hands are off the mouse and keyboard. You're going to see now, oops, it's gone, and whoops, it's back, but it's called a ranking. So that's good, but wait a second, this table had data in it. Let's right-click and view data, and sigh of relief, the data is still there. So the tool does the right thing. It renamed the table, not by dropping it and recreating it, of course, which would lose all our data, but by issuing, in fact, an SP rename. All right, so that, so we've done the refactoring, rename, and we've done that deployment. We're ready to create the stored procedure to update customer rankings. And here's where I'm going to issue a statement that, the purpose here is to demonstrate how to debug stored procedures using SSDT. Not necessarily that the implementation that I'm about to show you is the correct way to do this. In fact, it's probably not. What I want to do is create a stored procedure, and I'm going to do that. I don't, have a stored procedures folder yet because, like I said, at the time I imported the database into the project, I didn't have at least one. So I don't have a stored procedures folder. So I'll create it by hand, and inside of that stored procedures folder, I will create a stored procedure called USP rank customers. By the way, I anticipate that will be done in 10 minutes or less for those of you that are looking at the clock. All right, USP rank customers. And I've got the stored procedure tucked away here in Notepad. I'll just paste it in. And here's what I was kind of trying to warn you about. This is very contrived. This is not the way you'd want to do this for a number of reasons. First of all, as you can see, we're using a cursor here, which is, let's say, less than ideal. The cursor should always be avoided if possible. Secondly, this is a very static solution. If you look at what it's doing, it's opening a cursor to the view, and because the view is going to give us a sum of each customer's order total. And then based on that total, depending on what range of values it falls in, it'll assign a ranking value of 1, 2, 3, 4, or 5, and it'll update just that one customer, fetch the next customer from the cursor, and so on, and update each customer individually. So aside from the fact that we're using a cursor, which is undesirable, this is also a totally static solution. You're going to have to run this stored procedure on a regular basis in order to keep the customer ranking up to date. So in reality, you'd probably not want to use a cursor. You'd probably want some solution that would be more dynamically updating instead of this one. But for my sake and for yours, let's just go with it because we just want to focus on debugging. So the first thing I'm going to do is press F5, and that will, of course, deploy the stored procedure to the database. Yeah, there it is. And I'm going to set a breakpoint here. And if you've ever tried to get debugging working in SSMS or Visual Studio against SQL Server, you'll appreciate how easy this is to do. I just right-click on USP rank customers and say debug procedure. It opens a new query window that it sets to call the stored procedure. If the stored procedure was expecting parameters, I would first be prompted by a dialog to solicit those values from me, so that it could include them in the command line. I'm going to let this run to hit my breakpoint, and it hits my breakpoint. I've got my locals window open, and now I'm going to loop through my 4 customers that I have in local DB. I'll open the cursor, and I'll fetch my first customer, and now I'm going to stop for a moment and realize that, hey, when I pulled in some data from production into local DB, I only pulled in customer data. Remember, I grabbed 4 customers and pulled them in? I never grabbed any orders. Now, whether or not that was an oversight, I don't want to stop what I'm doing here. I don't want to break my flow here. So, but knowing, of course, that I pulled in no orders, every customer's order total is going to be 0. So when I pull from the view that does the sum of orders, it's always going to be 0. Every customer is going to get ranked as 1. So what I want to do is demonstrate how to use the debugger to assist us in debugging. Let's imagine that the value coming back from the view for this first customer was 5,000. And you can see it's the same debugging experience like you have with C#. I can single step. His order total is not 0, it's not less than 100, it's not less than 1,000, but it is less than 10,000. So ranking ID gets set to 4, and that customer gets updated. Okay, good. Let's fetch the next customer. Again, it'll be 0, but we'll fudge that to another value. This time we'll fudge that to be, let's say 150. So it's not 0. It's not less than 100, but it is less than 1,000, so this time it gets assigned a ranking ID of 3. We'll update that customer, and being a demo, I'm satisfied that I've done all the testing I need to do. Hopefully in production or in real projects, you do more extensive testing than that, but I'm satisfied. I'll press F5 to let it run all the way through, and just have a look at the table. And sure enough, the 4 and the 3, because I fudged the values, and all the remaining customers having a total dollar amount of 0, all got ranked as 1. So I'm pretty comfortable that this stored procedure works the way I want it to, and I'm having tested it on LocalDB with my project, I'm comfortable that it will run safely in production. So now I'm ready to deploy this to production. Basically, all the changes that I've been making throughout all this demo, except step 1, have only been made to my project and deployed to LocalDB, and now it's time to deploy them to production, to this database. And the way we'll do that is with a schema compare, yet another schema compare that we invoke by calling schema compare. It's the same concept, right? Except this time we're going to actually get to see graphically what the changes are. There's a source and a target. It was smart enough to figure out that the source should be the project. It figured that out from context, because I right-clicked on a project and said schema compare, so it set the project to be the source. We just have to select the target. Remember, it can be another project, because we're comparing 2 models, not 2 databases. So the source is a model backed by my project, but the target could be another project. Or it could be a database, which is what we want in this case, the production database. I'll say OK. Click compare, and let it compare the project with the database. And what you're going to see here in a moment are all the differences, all the things that have changed in production since we started working with our project, like the changes to the customer table. Production doesn't have the ranking ID column yet, and it certainly doesn't have that foreign key column constraint on that column. The view, we can see the changes to the view that we made, right? The correction of the case sensitivity issue, the capital D to the lowercase d. We can see the additional join in the from clause that didn't exist before. And of course, the 2 objects that we created brand new in our project that don't yet exist at all in production. So I'll go ahead and click update, although I could look at the script if I wanted, tweak the script, save it, run it later. Instead, I'll just click update, and it goes ahead and updates production. Now at this point, I should be okay to run the stored procedure in production, right? Actually, as a sanity check, I'm going to click compare one more time. We should see 0 differences, just to make us feel better. And indeed, if it ever comes back, we can see there are no differences, and that's good. Let me close all these open windows. And now we should be able to run the stored procedure, except for one thing, right? We don't actually have, and let me refresh. Right. In the ranking table, this ranking table is empty. We copy-pasted the 5 rows from Excel into the table on LocalDB, but then when we deployed that table to production, it was just a schema compare, so there's no data in this table, inside this ranking table. You can see it's empty. Now, I showed you the copy-paste trick already, so I'm going to show you another trick. I'm going to go back to LocalDB, which is where I have that table populated already. I'm going to view the data, and instead of doing a copy-paste, I'll click the script button. This is very handy. It generates insert statements for all the rows in the table. Of course, it's not going to work with a massively large number of rows, but for reasonably sized a set of rows, this is a very handy feature. It generated the insert statements. Of course, I'm inside of a query window that's connected to LocalDB. I want to run these against production, so it's very easy for me to change the connection of this window to be not LocalDB, but production. And of course, not the master database, but sample DB. And now I'll execute that. And now I should be ready to execute the stored procedure, exec USP, rank customer. Look at the IntelliSense, just kicks in automatically. I'll go ahead and execute that. And now let's have a look at the data. Star from customer and the view. And as we expected and as we would have hoped, everything worked perfectly. It assigned the correct values, and you can see how the view is doing the join correctly to give us the, to give us the appropriate labels of bronze, gold, etc. So that would be a wrap. There's one last part to this, which recall is getting this deployed to Azure. So we want to deploy this to Azure now. I already actually prepared this in advance of the session. So you can see on Azure, I've got a server here that I'm going to use, MUEA, it's a funky name. I'll just snag the database name. And now I'm going to go back over to my project, and I'll right-click on the project and go to Properties and go to Project Settings, and you can see that the target platform is set for SQL Server 2014. And what that means is that all along, the project has been validated against that version of SQL Server. Now that I'm intending to deploy to another version, specifically Azure SQL Database, and I try to build my project, I'll hit Control-Shift-B, it fails this time because there's something wrong with what? With the order header table. Does not have a clustered index. Let's look at that table. Indeed, it's not a primary key, and this was, of course, deliberate. I set this up to fail. And this is a problem that might have gone unnoticed on premises because it's not required to have a primary key. On SQL Azure, it's absolutely required that every table has a primary key. Although in the latest version 12 update to SQL Database, which is very recent, they removed that limitation. But I'm not running that update, so this is just a demonstration of how the project validates for different versions of SQL Server. You see the squiggly there, again, complaining that for this version of SQL Server, I need an index. Very simple to fix this. Just set that as the primary key, and now when I build, it builds successfully. And because it builds successfully, I can deploy to Azure. And you know something? That's just another type of schema compare exposed through the publish functionality. It's again just a schema compare with just a different UI. So the target database is that funky server name, and by the way, on Azure with the new portal, they have allowed you to create a name of your own as long as it's globally unique. This was created using the old portal, which generates this ugly name, .database, .windows, .net. Azure does not support Windows authentication. This is that hold your breath moment. I'm going to hope that this works because we certainly don't have time to try it again if it doesn't. The firewall is open. This should just work, and it looks like it is, which is good. It's done. That's great. And that means that we're pretty much done. If I go over to databases and refresh in the portal, you can see that the database has been created. Sample DB, come on. There it is. But I think what's more impressive than seeing it in the portal is actually inside of Visual Studio now. If we go over to the Object Explorer, look at this. A new connection has been added here to my cloud database. And if I expand it out, I can work with that cloud database in a connected fashion using SSDT, just like you saw for an on-prem database. Of course, there's no data in any of these rows because it was just schema that got written out to the cloud. Data migration is another topic, but for our purposes, we are done. We've pushed our way through our list. We've got everything done, including a deployment to Azure. So at this point, since I've gone over by about 5 minutes, I'm going to stop. I realize some folks may have had to leave already, but I will turn it over to anyone else that's on the line that might want to throw out some questions.
Any questions, anybody?
Hi, Lenny. This is Dan Field. I've been using data tools on a couple different projects now, and I really like a lot of the features, especially the source control stuff. That's really a phenomenal help. But one issue I've run into a few times is as I deal with more complicated databases and larger stored procedures like 1,000 line stored procedures and greater, it really starts to choke on me. And if I don't kind of like close quotes immediately, for example, it crashes a lot of times. Sometimes the model seems to get kind of confused and I have to delete the model file and restart it. Is there some setting I'm missing that would handle that, or when you're getting to that level of complexity, do you really just have to kind of stick with what I end up doing? Is I end up working in SSMS and then I use data tools to do schema compares from the database back against my project, and then I check that in.
But you're not maintaining a project. You're just working with directly against the database.
I'm maintaining a project, but when I start getting that level of complexity, I end up going into.
And then you work in the opposite direction. You go work directly on the live database, and you do a schema compare to push your changes back into the project.
Yeah, am I missing something there?
So let me say that I also have used SSDT in production scenarios. It's not just a sterile demo that looks and works great because it's tiny. I've worked with it on the Save the Children project, which is pretty large. I don't know that I've reached the level of 1,000+ lines in a store procedure, so I have not encountered the scalability problems that you're describing of it, like, choking on you. So I don't know that I can speak to that. I wouldn't mind taking a look, however, if you can send me the project that has those very large files. Maybe there's something that I can uncover that might help you. I'll also point out that I mentioned that some of the limitations, but once you start using it in production, there are other little gotchas that are kind of unique that I don't bother mentioning, that you just have to work your way around. It's like that with any tool. But for the most part, it works really well. If you're having a problem with large scripts, like 1,000+ lines, causing it to choke, I don't believe that should be happening. If you could send it to me, I can try to see if I can reproduce it, and I could certainly ping someone on the SSDT team over at Microsoft about it.
Yeah, and I'd say even with that, it's still great because as we make changes, if someone else on the team changes it, we can kind of look at the history in source control and roll back if we need to a previous version that did work. Or that.
Yeah. I mean, you're preaching to the choir. I love SSDT. I was working within its beta, and since I just can't live without it. And having a database project, which is like kind of inspired by the Data Dude product, right? They created the concept of a database project. It really makes all the world of difference in terms of, as you can see here, I've got more source control. While you were talking, I actually created another snapshot file. I can commit all this to source control now. I could do a schema compare between my current project. If I now start making more changes, stop. Go. Yeah. Come on. I can always refer to these backpacks. I can use them in a schema compare. It's just really a wonderful tool, and it's really very hard to go back to working, imperatively in a connected way using SSMS once you get used to all these benefits.